A glacier is made of ice. The ice that makes up the glacier was originally snow that fell on the glacier, but then the snow underwent different modifications. One of these modifications is ablation. Ablation occurs when melting and sublimation happens on the glacier, and ablation usually occurs in the summer months in most glaciers.
If snow survives the summer ablation, it becomes neve, which has a new density of 500 kilograms per meter squared. Or if the neve survives the summer ablation process, it becomes firn, which is even more dense and compacted. As firn accumulates over decades, it becomes glacial ice, which has a new density of 1,000 kilograms per meter cubed. The transformation of neve to glacial ice could take up to 25 to 100 years. Here are some terms you might want to know to understand better the process of glacial formation and movement.
Terminus, the front area of a glacier which moves forward. Ablation, melting and sublimation of solid and liquid forms of water. Zone of accumulation, the top part of the glacier where snow can survive the entire year. Zone of ablation, the area towards the terminus in which snow melts.
Mass balance. Mass balance refers to the balance between the amount of accumulation of snow on the glacier versus the amount of melting towards the bottom near the terminus. A positive mass balance means that more snow is accumulated than melted. In this case, the glacier gains ground, and negative mass balance loses ground, but
what do you say we talk about friction? As we all know, kinetic friction is a force encountered when two different surfaces slide against one another with a finite relative speed. Friction opposes a sliding motion at the point of contact between two surfaces. The force of friction is equal to the coefficient of friction times the normal force to the object in contact. And the coefficient of friction has a constant numerical value between 0 and 1. The greater the value, the greater the frictional force. And also, the larger the mass, the larger the normal force.
Because glaciers have a large mass, we would expect the frictional force acting on that glacier to be quite large. The coefficient of friction on a glacier on bedrock is between 0.05 and 0.08, a relatively small value. However, the greater amount of sediment that is present in a glacier can increase that value. However, later in this video, we will show you how the force of friction can often be negated with glacier movement. Now let's examine the amount of work that a glacier does, and also if the force of friction does any significant amount of work on a glacier. Work is equal to the force exerted multiplied by the distance over which that force is exerted. A large force over a small area is equal to a small force exerted over a large area. Work is also equal to the change in kinetic energy, or 1/2 mass times velocity final squared minus 1/2 mass times velocity initial squared. The work of a glacier can be understood as the glacier moves downhill from the zone of accumulation to the zone of ablation. The velocity final in the zone of ablation will be substantially greater than the initial velocity in the zone of accumulation. As the glacier moves downhill, we will see that the force of friction will be a relatively small factor in determining the speed of the glacier.
Now, I'm going to talk about the power of a glacier.
Kapow!
Power is the measure of how quickly work can be done.
Do work!
Power is equal to the amount of work done over the time it took to do that work. Power relates to a glacier. We'll soon find out that it has more power at the top versus the bottom.
Picture shows that the force of friction is significant at the bottom of a glacier, as the top moves much more quickly than the bottom, because the bottom is in constant contact with the earth.
Also, it has a greater power going downhill than uphill.
So let's talk about power. Power is energy over time. So which one of us has more power right now? Oh, that's right. It's me. I have more power because I'm doing the same amount. I'm doing more work than Dar is at the same amount of time.
That was actually good.
Work equals force times distance. Power.
I'm living in that 21st century, doing something mean to music. No one man should have all that power. The clock's ticking, I just count the hours. Stop tripping, I'm tripping off the power.
Oh In this case, Dari and I both ran the same distance and did the same amount of work, but he ran faster and therefore did it in a shorter period of time, and therefore his power was greater than mine. Today we're going to be talking to you about glacial movement. It's a serious thing and it's affecting people all over the world. To be a glacier, a mass must be able to move. That's important. Dari, what do you think?
Well, yeah, because to the naked eye, a glacier looks like it's stationary, correct?
It's not stationary, Dari.
It's always in motion. Forward motion of glacial ice is controlled by gravity and accumulation.
If losses due to ablation are equal to the accumulation in the accumulation zone, the glacier will appear to be stationary, but in fact, we know it's moving.
Advance of the terminus occurs when accumulation is greater than net ablation.
Wow. What a reaction! Glacier retreat. A serious issue we want to talk about is glacier retreat. It's happening all around the world, especially in Greenland. Do you know that a glacial retreat occurs when net accumulation is less than the net ablation?
Didn't know
True
that.
fact.
True.
Look it up.
I will. Another process that can remove mass from a glacier is called calving.
Calvin?
Calvin.
Nowhere.
This process occurs in glaciers whose terminus reaches large bodies of water.
The deep end. Calvin involves portions of the glacier entering the water and separating. Many icebergs enter the oceans, the calving of Greenland's and Antarctica's glaciers. Shout out to Al Gore.
Most glaciers are retreating now because of global warming.
What?
I said it. The mass balance is negative because the snow accumulation is less than the snow's ablation.
Whoa, hit me with some algebra. Alright, let's get back to friction anyways. Now what this project is about? The bottom of the glacier. The greatest effect friction has on a glacier is that it creates heat at the bottom of the glacier, which melts some of the ice, therefore lubricating that ice to move more quickly, causing basal sliding. You heard it, basal sliding. In order to picture basal sliding, consider this picture. A kid trying to slide down a slip and slide with no water on it. That is what a glacier would be like, moving down a hill without any water at the bottom. Instead, picture a kid moving down a slip and slide with water on it, being able to move much more freely. That is the effect that friction has at the bottom of a glacier, which creates water, which makes the glacier able to move down the hill. In essence, the impact of friction is that it negates its own friction. When the ice is lubricating the ice, or when the water is lubricating the ice, it reduces all the friction that was there in the first place.
No friction?
Friction ends friction.
Although counterintuitive, wrong camera. Although counterintuitive in the case of glacial movement, friction helps to increase speed and thus increasing the power.
Wait a minute, I thought we said that friction opposes motion.
Not in glacial movement.
Whoa. This just in. As time goes on and temperatures increase, so do speeds, and thus the power of a glacier. The power of a glacier increases as it moves downhill due to friction, gravity, heating, and greater area for expansion. You heard it here first, people. Al Gore was right.
Al Gore don't tell no lies.
Greenhouse gases are it. So, friction and time, the power of glaciers. We've learned that the glaciers are slowly melting due to global warming, aka Al Gore, who created global warming.
Didn't he get a Nobel Prize for that?
He won some kind of trinket, that's what I heard. Anyways, as the glacier moves downhill, it increases speeds, it gains heat, and therefore it just melts. And at the bottom, the melting of the ice creates lubrication to fight the friction that was holding it back before. And so while the friction at the top during the zone of accumulation may hinder the motion of a glacier, towards the zone of ablation, friction has no effect. And thus the glaciers are moving, melting, and eventually they're going to enter all the oceans and just melt and create terrible flooding. This is 2012 stuff, people.
2012. It's coming soon to a globe near you. So, in conclusion, I just want to say, first of all, happy holidays from me and Riley Nowak, and enjoy your physics classes, gentlemen.